So in today's video, I want to show you how I went about solving exploit number 10, combination lock, found here on the Solidity Challenges repo. To get started, let's simply clone our repo and open it up in our editor. I'm over here on the README, where it states, a seemingly simple combination lock stands between you and glory. And our mission is to submit a combination of 3 distinct numbers between 1 and 255 inclusively from the test file. Confirm your success by running the test. To win, you must achieve the lowest possible sum. All right, well, instructions are pretty simple. Let's go take a look at the contract. This contract stores a winning combination hash that's set by the constructor. Then it has two functions, a submit combination and verify solution. So initially, we need to pass in 3 numbers that represent our combination. It's going to check that each number is indeed unique. It's then going to sum the numbers up and then hash them and return them back to us. So we're going to get a solution hash. Once we have that, we take the hash, we call verify solution, and it's going to be checked against this hash that is on file. All right, so in the test, all we need to do is call this function here, test submit combination, and it tells us pass in the correct combination here. So we'll replace these 3 numbers with 3 numbers that we think will produce the lowest combination value. So you wouldn't be wrong if you were thinking that the easiest way to pass this is simply to put 1, 2, 3. Well, these numbers obviously will produce 6, and that should be the lowest possible combination that we can provide. So why don't we just test it? We go over the terminal. I have the command already loaded. Hit enter. And we fail. So it tells us here when they verify solution that we do not pass the assertion. And here the assertion is the winning combination. Is the winning combination passing when we call verify solution? No. So our hash of 1, 2, 3 does not match the hash that they provide here in the test. All right, so let's revisit the contract and see why this is. All right, so back on the contract, when we submit our combination, it verified that they were all unique, so nothing to worry about there. But then when they sum them up, you can see they're using this unchecked keyword here. So with that, the compiler is not going to run any checks, any tests. It's looking for, in this example, it's looking for an overflow or an underflow, right? So this version of Solidity, 8 or greater, if we don't use unchecked by default, it's going to ensure that we are not able to overflow. But now that we are wrapping our logic in an unchecked, the compiler is going to just simply ignore it. So 1, 2, 3 will produce 6, but if we pass in numbers that will cause our integer, our uint, to overflow, then we can actually get a lower number. The numbers that we are passing, they're using a uint 8. So the largest possible number that we can store in that value type would be 255. So knowing this, if we were to go even 1 higher than that, it will wrap around to 0. So let's give that a try. So in order to produce 255 plus 1 or 256, we just need these numbers to equal that. So you can use your own combination of numbers. As long as the sum is the same, we're all winning. So I'm going to go with 255 and then 1. We'll go to our terminal, clear this, rerun it, and boom, there we go. And we have passed. So this exercise or this challenge is all about integer overflow. If you happen to approach this challenge differently, let me know. You can find my contact information in the details below. See you in the next one.